So what transformations are necessary to map a circle with center -2, 1 and a diameter of 6? Make sure you convert that to a radius, which would be 3. Map that onto a circle with equation x minus 3, y plus 2 equals 36. So pull out the center from this. Remember to change the signs. -3 turns 3, +2 is -2, and the radius is 6. So to get your transformations, you have to translate the center from -2, 1 to 3, -2. So you're going to translate with the vector. You have to go from -2 to +3, so to do that you add 5, so +5. And then for your y coordinate, you're going from 1 to -2. To get from 1 to -2, you subtract 3. So there's your translation vector. To determine your dilation, we need the scale factor. The scale factor is found by doing the image divided by the pre-image. The image, we just care about the radius. That's the only thing that determines the size of a circle. So the radius of the image, so the after, is 6. And then the pre-image, the before, the radius was 3. 6 over 3, scale factor is 2. So we translate with the vector 5, -3, and dilate with a scale factor of 2. Determine y such that 2, y is on the circle with center -2, 4 and a radius of 5. There will be 2 answers to this. There will be 2 different values of y that are going to work out. To come up with those, we're going to take our center and create the equation. So x minus -2, that's x plus 2. Y minus 4. And then the radius squared is 25. Then you plug in the point 2, y. So we plug in 2 for x. And we keep y for y. So that's 4 squared plus y minus 4 squared. 4 squared is 16. So we're going to subtract 16 so we can get the y expression by itself. Uh, 25 minus 16 is 9. Then here's where your 2 answers come from. When you square root to get rid of the square, your answer is positive and negative, plus or minus the square root. So you end up getting 2 equations you have to solve. You have y minus 4 equals a positive 3, and y minus 4 equals -3. Always plus or minus the square root. So you solve both of those equations. We're going to add 4. So you get y equals 7, and then you add 4, so you get y equals 1. There's our 2 values for y. Here we have a quadrilateral inscribed in a circle. when you have a quadrilateral inscribed in a circle, angles that are opposite each other, that are across from each other, will always add to 180. So angle D and B will add to 180. Angle A and C will add to 180. We're trying to find angle A. A and C add to 180, so it would be 180 minus 70 is 110. Almost the same question, it's just a little more difficult. Angle A is over here, angle C is right here. They are across from each other, which means they add to 180. They're opposite angles. So they add to equal 180. So we have our equation. Combine like terms. 7x minus 30 add the 30 over, you get 210. And divide to get x equals 30. But it doesn't say what's the value of x, it says what's the measure of angle C. So we're going to plug the 30 in to find the measure of angle C. That's 4 times 30 minus 25. That's 120 minus 25, which is 95 degrees. In the diagram, we have an inscribed quadrilateral. It says by using the exterior angles of the quadrilateral, which triangles can be proven similar. So what that means is we have angle X and we have angle Y, or V, sorry. We know that those two angles are going to add to be 180. That's the same formula, the same theorem we used on these last two equations, last two questions. We also know right here that's a straight line. So that means this angle right here at X plus this angle will also add to 180. So that means angle V and angle YXZ have to be the same thing, because X adds to 180 with both of those angles. So they have to be the same. You can apply the exact same concept over here. This angle at Z is supplementary with angle W. So is this side of Z. That's also supplementary. So that means W and XZY are also congruent. So we have angle-angle similarity amongst this large triangle. Let's name it triangle YWV. And when you're naming triangles, you have to name them in corresponding order. So if we started with Y in the first one, we have to start with Y in the smaller triangle. Next, we went to angle W, which corresponds down here with this angle at Z. So Z needs to be second. And then last, we ended with V, which corresponds with this angle over here at X. Make sure you name them in corresponding order. So here we have this Salinon, which is 4 semicircles. We have a semicircle there, semicircle there, semicircle there, and then the big semicircle. So if you're to find the area, I would start by finding the big semicircle. So to find the area of a circle, it's pi r squared. If it's a semicircle, it's 1/2 because it's half a circle. So we need the radius. I'll do this in black writing so it matches up. So the radius of this entire semicircle, the big huge one, the diameter we can see is 4 plus 6 plus 4, that's 14, which means the radius is 7. So you multiply that out and you get 76.93, that's inches squared. And that's for the black semicircle. Now we have the blue semicircle and the red semicircle. I'm going to group them together because they're the same, they're 2/2 of the same circle. They have the same diameter, 4 inches, so they are 2/2 of the same circle. So if you have 2/2, you just have a whole circle. So you have pi times radius, which would be 2 squared. We don't need to do the 1/2 because the blue and the red together makes a full circle. So I'm actually going to be clever here, and I'll do that in purple because blue and red together makes purple. So 4 times 3.14, you get that the combined area of the blue and the red is 12.56. Now, looking at that figure, the blue and the red circle, they're both cut out of our original. So we're going to subtract those when we're figuring out our final answer here. We'll do the black semicircle minus the blue and the red semicircle. And we have to add the green semicircle. So that's again a semicircle, so it's 1/2 times pi times the radius, which is going to be 3 squared. So 1/2 times 3.14 times 9 is 14.13. We are subtracting the blue, we are subtracting the red, so we are subtracting the 12.56, but the green is added on. It's an additional area. So to get our final answer, we just needed 76.93 minus 12.56 plus 14.13. For a grand total area of 78.5 square inches. If this circle, the semicircle in the middle, if that was the same size as the blue and or the red, then I would just cancel them out. This circle would fill in the other one, and then you won't have to worry about either of those 2 points. Make sure you visually fill in gaps with whatever can be filled in so you can make the problem a little bit easier. Describe the 3 ways to change the construction to a hexagon. You can rotate the triangle. (180 degrees), so it's upside down. You can construct angle bisectors. So that intersects a circle and you get 6 points. And the third way is you can construct segment bisectors. We have a regular polygon inscribed inside a circle that has a radius of 3. A polygon that is inscribed in a circle is limited. It cannot become larger than the circle itself. And perimeter is a lot like circumference. So it is limited by the circumference. So you find the circumference of that circle, 2 pi r. So that's 6 times 3.14. The perimeter would be limited. It cannot be more than 18.84. Because it cannot be more than the circumference of the circle. Determine the diameter and write the equation of a circle with the diameter endpoints -6, -3, and 9, 5. So we're told the endpoints of the diameter. If you wanted to, you could graph these. You don't really need to. To determine the diameter, you just need to know what the length is of the diameter. So we're going to do distance formula. Distance formula is x2 minus x1 squared, y2 minus y1 squared. Then we fill in the points. 9 minus -6, and 5 minus -3. So 15 squared plus 8 squared, that's 225, plus 64 is 289. So the third side, or the diameter length, is 17. There's the first part. The diameter length is 17. Now, to write the equation of the circle, we need to know the center. The center is the middle of the diameter. Midpoint, the midpoint of the diameter. So we're going to find the midpoint of these same 2 points. So we're going to do x1 plus x2 divided by 2, y1 plus y2 divided by 2. So I would write that as 1.5 comma 1. So that's our center. That's the middle of the diameter, the center. This is the diameter. So we know the center. When we're writing our equation, it's x minus the x coordinate y minus the y coordinate equals radius squared. If the diameter is 17, that means the radius is 8.5. So then you square that to get 72.25. There's the equation of the circle. We have the center in there. We've got the radius squared in there. So here we have two circles. We're given the center and a point on the circle, and then a center and a point on the other circle. Explain how to determine they are congruent. Well, we know the center and the point, so we're going to find the distance between those points to get the radius. To get the radius by using the distance formula. And if they have the same radius, then they're congruent. So for this exact question, when you determine the radius of each one, you first get a radius of 10 for circle A. Then you do the same thing for circle B. Takes a little bit longer. You have to use distance formula, but you also get that the radius is also 10. So both radii are 10, so they are congruent. We've got two circles. We need to state the transformations that show that they are similar. So you don't have to use the graph. You could just think it through a little bit. You have to move the center from 3 to 4 and from 5 to 0. So to get from 3 to 4, you have to add 1. To get from 5 to 0, you have to subtract 5. So here's our vector that we're going to use to translate. You have to add 1, subtract 5. And then the radius has to go from 6 to 3. So you put the image, which is 3, over the pre-image, which is 6. That gives you the scale factor is 1/2. So you will dilate with k equals 1/2. The scale factor equals 1/2. To construct a square inscribed in a circle, you just start first with a line. Then from that line, you are going to create the perpendicular bisector. So to do that, you start at one endpoint, stretch more than halfway, draw a semicircle. Do the same thing from the other endpoint. Then draw, with a straight edge, your perpendicular bisector. Then using that intersection right there, you draw a circle as large as you want. I would choose it to be a little bit small so it fits on here. There's your circle. And to get the square, you just connect these 4 points where it intersected the circle, and that's your square. on your own.